And we're back with part 3. Welcome back, college algebra. Okay, this is probably the part most everybody's going to be watching on Tuesday for sure. So let's finish out section 5.3. And let's start with something fairly easy. We're going to be finding logarithms with a calculator. Finding the value of a logarithm with a calculator. Now, this is example 343, number 56. Where it says to use a calculator. Find the following using a calculator and round to 4 decimal places. So all I need to show you is where the buttons are on your calculator. So here we go. On the left side of the keyboard on the graphing calculator, TI-80 such and such, I think that even the 82 would have to be something similar to this. 83 and 84 for sure. The log button is right there next to the 7. So if I want log of 8, I just type log 8 and boom, hit enter. There it is. And so I need 4 decimal places. So I'm going to say it's 0.9031 because it's got an 8 after the 0. Boom, there we go. That is the answer to number 56. It's just that easy. Number 64. Notice before I do that, right underneath the log, which remember is common log, base what? 10, base 10. There's an understood base 10. So 10, in other words, 10 to the 0.9031 should be very close to 8. That's the exponent on the base number 10 that should come out to result in 8. And you could, of course, check this on your calculator by typing that in right there. And also, I was going to point out right underneath that is the ln. Log with a natural base, log base E. So for number 64, when I tried to type this into my calculator, which I typed in LN, I think on the screen it would actually be, it's a capital LN on the button, but I think it would just show a lowercase ln on the screen, and then I put -4 in. And you don't even have to close the parentheses. You can if you want. And I hit enter. This is what came up. Non-real answer. Okay, because what I'm asking it to find is this. That's the same thing as saying log with a base of E of -4 equals what? And then be saying E to the what? E to the X, so to speak, equals -4. There is no such exponent in the real number system that you can put on the base of any number and come out with a negative. Remember, even a negative exponent is a reciprocal, which would make it like 1 over a number. But it's always positive. Always positive. You can't have an exponential function result in a negative. Remember, there's that baseline on the graph. You'd have something like this, and you have this explosion up. But on the left side, it would have this baseline of the x-axis, which would be y of 0. Right? It never gets below the y of 0, and it never even gets to the y of 0. It gets infinitely close, but it never even gets to 0. So this couldn't even, this negative, or it couldn't even be 0. It'd be the same thing. It would tell you it's a non-real answer. There is an answer for that, but it's an imaginary number. You get into the imaginary numbers, you probably have to go into master's degree level math, and I had a whole course on that. But that is not college algebra. That's way beyond that. So we're just going to say, you can say right here, you can say non-real for your answer. The book says undefined. But I kind of don't like that because it is defined. It's just not defined as a real number. It's kind of like saying I is undefined. Well, I mean, undefined is a real number, but it's a thing, okay? So, yeah, either way, though, I mean, that's what you're going to find in the back of the book, undefined. I'm going to say non-real, as the calculator says, and move on. Okay, so there's not a real number we can put as the answer for that. Okay, so let's move on to the next topic. Change of base formula. Change of base. Back in my day, we had a music group called Ace of Base, which kind of, I was thinking of them when I hear this, change of base. Let's play their music for you sometime. Good stuff back in the day. Okay, so anyway, this is change of base, not ace of base. Change of base. This formula can be used to change the base of a logarithm. Okay, so as I explained here, some calculators only have logarithmic functions for base 10, the common log, which is, just the log button, or base e, natural log, right, which was the ln button, log with natural base, right? So if you don't have the newer operating system, as I was saying in the video number 1, then you can't do like a log base 2 or a log base 3 or a log base 5 or whatever on your calculator. You can't have it calculate. Just, you don't have a button that you can say, what's log base 2 of 20? Or in the example for number 70, log base 3 of 20. You don't have a button for that, right? So you need to change, in that case, you need to change the base number to either 10 or E so that your calculator can perform the calculation for you, okay? Or you're just going to have to do a lot of guess and check to figure it out, right? Otherwise. So, because, 1 exponent of 3 would come out to 20. Well, I don't know, 3 to the third is 27. So had to be something a little less than 3, right? So, it'd be hard to guess. This formula says you can if you want, if you have some, log of some base number, and you want to calculate what that is with a number n. Notice I'm using a big N here. You can do log of a different base, right? So notice up here, now this is an A instead of a B, right? So this is a different number. So this is whatever your desired base is. You're doing log of a different base number and you do the big log of the big number on top, the big N number goes on top, boop, log of that on top, and then log of the original base number on the bottom. The little base number goes on the bottom, right? So as you see what I did here, to use the change of base, if I don't have the new operating system and all I have access to on my calculator is common log or natural log, no problem. I can change this into, and it said to use common logs on this problem. So just the basic, just the log button. Log, and this would be base 10 of the big number 20 goes on top, right? So log of 20 divided by log of the original base number 3. And notice that's what I did on the calculator. I did common log of 20 divided by a common log of 3, and there it is. It gives me the answer I'm looking for, right? So to answer, this is the answer to the question 3 with what exponent results in 20? And it should be, okay, so again, we're asked to, actually we're not asked to round this off, but it would probably be wise to do so. Right, so I would probably say, earlier we're looking for 4 decimal places, so I would probably say 2.7268, and it would stay in 8 because there's a 3. So that would be my answer to that problem. So 3 to the power of 2.7268 should be approximately 20. And again, you could check that on your calculator and see if that's actually accurate. So it should be really close. So that's going to be pretty easy problems for you if you know the change of base formula right there. Oh, speaking of that, real quick before I move on to the next problem. Because it says to use common logs, I do want to see on your paper this right here. I want to see, what you typed in basically on your calculator, log of 20 over log of 3, along with your answer to that. Okay, just to show me you use the common log in the formula. Okay, that's all I need to see right there. I want to see the change of base as well as your answer. Okay, so now on to number 76. It's basically the same type of problem, but notice now it says using natural logarithms in the change of base formula. So I'm going to use the natural log, as you see I typed in here on the calculator. So on your paper, I would be looking for this log with the natural base, ln of the big number 25 divided by ln of the little base number 4. And as you can see on the calculator screen, it works out to about 2.3219 right there. I want to see that as the answer. And again, what we've answered there is to say if with the base e, the exponent of 2.3219 approximately should result in 4. Okay. And again, you can check that on your calculator. There we go. Okay, moving on. Not too bad there. You finish up with a couple of application problems. The one before this is the pH scale, which I might just make a comment about that, so I don't have that example on here, but maybe I'll write that in here just real quick. The pH scale, the formula, it's a logarithm scale. It's common log, and it's got a negative log, and then it's got this bracket with an H plus in there. Okay, the H plus is like this concentration of hydrogen ions, and this is just a number. And so on that problem, you're given several of these numbers, and all you have to do is plug them in to this formula. Okay, all you're going to do, there's several of them, but they're pretty easy. So if let's say the H hydrogen ion number is, I'm just going to make something up, 2.5. And a lot of times they're giving it to you in scientific notation. 2.5 times 10 to the negative 5. I don't know. You literally can just type that into your calculator to figure it out. Okay, they're not asking you to do any fancy evaluation thing or whatever. It's just type in your calculator negative In fact, I'll show you right now. And there's even a shortcut button for scientific notation. I'll go ahead and show you that too while I'm at it here. Okay, so all you got to type in is negative log, and then you can type the number in just as it shows, like 2.5 times 10 to the power of -5. And I don't even have to close the parentheses. I just hit equals, and there's my answer. There's the pH for whatever that substance is, right? The shortcut for the scientific notation, the times 10 to the whatever, is this, if you want to use it. I could do the same thing as negative log of 2.5. And notice the comma button above the 7. And in blue, there is an EE, a double E. That's something abbreviation for an exponential thing. Basically, that is for scientific notation. Okay, so I'll push second comma, and it just brings up one E. And all I need to do is type the exponent of -5. And there we go. So it saves me typing in the times 10 to, and then the power button. I just type in the power after that. Okay, so not a huge time saver, but a little bit. If you're doing a lot of them, that might save you some keystrokes there. Okay, all right. So that's all you got to do on that problem. So I didn't have that example. Let me go back to the last one. I thought maybe would require a little more discussion to set the background. Okay, so I copied what the book said about this decibel equation, and I won't read all that to you. You can read it for yourself. You've probably heard of decibels. It has to do with the loudness of a sound. The actual unit, this is a unit of measure. The measure of loudness is bells, named after Alexander Graham Bell. Okay, so there's an equation for how many bells of sound some type of sound has, how loud it is. But bells are a really big unit, so we use decibels for our typical unit, so they're not such big numbers. Okay, so the subunit, as they call it, is decibel. That's what we usually use. You've probably heard of that. And here is the formula for that right here. And it's based on this thing called intensity of the sound. And it's usually given as a ratio of some base intensity of, like, compared to kind of a very low baseline sound. Like how much more intense, how many times more intense it is than this little I sub 0, like the sub 0. So we're saying the intensity of kind of a 0 level, not necessarily 0 decibels, but this baseline level intensity sound. Okay, so for example, you're given some, again, several to calculate based on this, but most of this you can use your calculator for. But let me show you how you're going to set this up to calculate it. Okay, so for my loudness in decibels, if this is the intensity of the sound, this is true. I actually looked this up. For a loud siren, it says it's this. All right. This is my, as it says, given intensity. This is my I, right? So this is going to take the place of the I in my equation. So it's going to look like this. 10 times common log of 10 to the 12th times I sub 0 divided by I sub 0. Okay, so it's 10 to the 12 times as intense as this base intensity sound. Okay, so just some simple algebra here. The I sub 0 cancels out, right? So what I got is 10 times the common log of simply 10 to the 12th. That's it. Okay, so from here on, you literally could type this in your calculator to figure it out. But I want to point something else out as well. If you want to just use your calculator, that's great. Go for that. But if you really understand what's going on here, you wouldn't even have to do that. Because, okay, common log of 10 to the 12th is like saying, remember the base is 10. Base is 10, right? So we're saying 10 to the x, 10 to the what, equals 10 to the 12th. Well, duh, it's the exponent is 12, right? So this would be the same thing as 10 times just 12. Like literally 12 would be what log of 10 to the 12th is. It's kind of like the log and the 10 cancel out. Ooh, we're going to talk about that in the next section. So it's just 10 times 12, which is easy peasy. That's just 120. Boom. And that's the answer to that. It's 120 decibels of sound. That's pretty loud. That probably would hurt your ears a little bit. Kind of like when you walk outside when the fire alarm's going off. It's basically what that would be like as you walk by the siren in the school. Okay, that should pretty much help you finish up. And obviously, you can always ask me questions. Feel free to send me an email if I'm not around. If I'm at Scholars Bowl, I'll try to answer your email. Probably in the evening before school the next day, or you can find me at school the next day. Find me homeroom on Wednesday, or whenever we need to. We can figure something out. Okay, and talk to me in class Wednesday. So good luck. Hope this helps, and take care. We'll look forward to seeing you guys on Wednesday. Bye bye.